Let's talk about a new concept called concentration. And concentration, whenever you see this word, understand that it always deals with solutions. So what is concentration? Concentration just measures, how concentrated something is. So for example, what it really is how many moles of solute per liters of solution. But you can sort of think of it like, for example, apple juice. If it's more concentrated, it'll have a stronger flavor. You can sort of think of it like that. Now we measure concentration in molarity. Okay, not moles. There's not moles. There's not molar mass. This is molarity. It's something completely different. And you calculate it by finding the moles of solute divided by the liters of solution. Okay? Now keep in mind that molarity is only for aqueous solutions. So it's for compounds dissolved in water. And it's the liters of solution, not solvent. Okay, not solvent. So if a question asks, 50 grams of NaCl, that is, takes up 25 milliliters of volume, and 100 grams of water are mixed together. What's the molarity? If you find the liters of solution, it's the 25 milliliters plus the 100 milliliters, because the fact that 1 gram of water takes up 1 milliliter of volume. So the final volume solution would be 125 milliliters, not 125. Okay, because you would divide the moles by the total volume of the solution, which would be in liters, right? Because liters measures volume. Okay, so this is molarity, and it just measures how concentrated something is. So for example, something that has a molarity of 3 is greater than, let's say a concentration of 1 molarity. So, this might be 1 molarity, this might be 3 molarity. There's more moles in a given volume, right? For example, if, let's say 3 molar would be 3 moles divided by 1 liter, okay? Whereas 1 mole would be 1 molarity, 1 molarity would be 1 mole per 1 liter. So if there's only 1 mole per 1 liter, there's less stuff inside. Whereas if you have 3 moles per 1 liter, there's more stuff. It's more concentrated, right? It's like more concentrated apple juice. Now, the units for molarity, if you haven't said, is moles per liter. Okay? And oftentimes, when something is, for example, 6.7 molarity, all that means is there's 6.7 moles per 1 liter of solution. Okay? Per 1 liter, right? It's just exact same as, molar mass. Like, the idea is the same as molar mass. If you have, a molar mass of 77 grams per mole, it's that 1 mole has 77 grams. Okay? Same thing. 6.7 moles in 1 liter. So that is molarity. Molarity measures concentration. So molarity is a unit. Okay? When it asks for concentration, your unit is going to be in molarity. So it's similar to saying, what's the distance? What's the distance? You measure it in meters. Okay, meters would be the molarity, concentration would be the distance. Okay, molarity measures concentration, and it's calculated by moles of solute divided by liters of solution, not solvent, liters of solution. So it's after you add the solute. Remember, solution is solute plus solvent. So when you add the solute and solvent together, what's the volume? And you would have moles. Okay, so the equation would be molarity is equal to moles times over volume. Okay, I should change that from a V. Okay, molarity is equal to moles over volume. So in this example, it's more concentrated. It would have a higher molarity than this one because there's just more stuff in a given amount of volume. Okay, we could have had another example where you have 1, 2, 3 particles here, and let's say it's a bigger container, but now there's 1, 2, 3, 4, 5, 6, 7, 8, 9, right? Do these have greater or more molarity? Which one is more concentrated? Well, the fact is you don't know. If this volume is 3 times more than this volume, they would have the same concentration, because even though this, let's say, balloon A, even balloon A has more particles, 1, 2, 3, 4, 5, 6, 7, 8, 8, 9. Even though it has 3 times more particles, it could just be 3 times bigger. Even though it might have 3 times more moles, it could just have, 3 times more volume. It's like, 1 mole per 1 liter versus 3 moles per 3 liters, okay? 3 times more volume, 3 times more, more particles. And in that case, they would be the same concentration. So concentration, molarity, does not measure moles, okay? Molarity measures concentration, how many moles per a given volume. It measures how concentrated something is. It doesn't measure that. It doesn't matter how many particles there are. Something could be extremely concentrated. Something could be like, 100 molarity, but only be, 0.01 moles, right? That just means the volume is super small, right? You would have a really small volume, okay? So that is concentration. Let's do an example of calculating molarity. So calculating concentration. What is the molarity of a solution? So it's asking for concentration. Made by dissolving 2.355 grams of sulfuric acid in water and diluting to a final volume of 50 milliliters. Okay, so final volume. So this indicates that it's the solvent plus solute. Okay? And we're given mass. Well, we know what to do with mass. Molarity, concentration, is equal to moles per volume. Okay? Now we have volume. That's 50 milliliters. But remember, it's in liters of solution. The unit is liters. So we got to convert this 50 milliliters to liters, and this is something you commonly do because scientists work with milliliters more often. You don't usually have, 2-liter beakers, 3-liter beakers. They do exist, but they're not as common. Usually we have, 100 milliliter beakers or 150 milliliter graduated cylinders. So 50 milliliters is how many? Well, we can do our dimensional analysis or just knowing that 1 liter is equal to 1,000 milliliters. But let's do our dimensional analysis. We have 50.0 milliliters. Okay, milliliters goes on the bottom. Liters goes on the top. Liter is a bigger unit, so we make it 1. And the smaller unit is milliliters. How many? 1,000. Cancel, cancel. And what you get is 0.050 liters. So 50 milliliters is 0.050 liters. What I do is just memorize. You have to move the decimal place 1, 2, 3. Okay, so 1, 2, 1, 2, 3. 3 places because it's 1 liter is equal to 1,000, so 3 decimal places. Okay. So we have volume. Volume is 0.050. What's moles? Well, we know how to calculate moles. We have mass, and we're given the compound. And from compound, we can find molar mass. Remember? So we have moles is equal to mass over molar mass. Okay? 2.355 grams divided by molar mass, and that is why we had the periodic table here. We had sulfuric acid, H2SO4. So hydrogen is 1.01, 1.01. We have 2 of these, so we multiply this by 2. Plus sulfate, S over here is 32.7 plus 32.07 plus oxygen is 16.0, but there's 4 of those, and we will get a molar mass of 2.02 plus 32.07 plus 16 times 4 of 98.09. Okay, so 98.09. Awesome. Okay, 98.09. That is grams per mole. Oh crap, 98.09 grams per mole. Cancel up grams. Moles goes on the top. And we get how many moles of sulfuric acid? 2.355 divided by 98.09. We get 0.024 moles. Okay? Because keep in mind, molarity deals with moles, not mass. We don't use mass. And oftentimes in chemistry, we don't really like working with mass because mass tells us nothing. Moles tells us more because moles tells us about the individual molecules, how many molecules or how many compounds or how many atoms there actually are. Mass doesn't give us that information. We almost always want to convert to moles when we have mass. Okay, so 0.024 moles. And so we have moles, and we have volume, well, we can do it, right? Molarity is equal to moles over volume. Moles is 0.024 divided by volume, 0.05 liters, and there's in moles. And when we do that, we get 0.024 over 0.05. We get 0.48, okay? Okay, molarity. And we see that even though our moles are really small and our volume is also really small, we still get, a concentration that is pretty high. Well, relatively, right? This is, this has two zeros here. This has 1 0 here. And this doesn't have any zeros to the right of the decimal place. So it just shows that something, even though the moles we have are really low, as long as we have it a equally small volume, the molarity can still be a high value. Okay, so molarity is always about concentration, not about moles. Okay, and you also want to memorize this beautiful formula. Molarity is equal to moles over volume. I sometimes see a triangle here. If that helps you memorize it, molarity and then moles volume. So moles is equal to molarity times volume, which what we will use often. Volume is equal to moles over molarity. You can also use this triangle for the previous unit. I believe it was moles is equal to mass over molar mass. Okay, so anything that helps you remember, right? But just know this formula inside and out.